3D plots. So if you see in the previous 3D plots, we have understood how to use the surf command. Now when we have a three-dimensional independent variables like x, y and z, previously we only had x and y. So in this case we want to plot at different cuts of z, y or x. So how to do that slicing at different cuts, we are going to learn in this particular tutorial. So you can see this is the same graph what we have used previously, same equation. This equation is Z3 in the previous lecture. So right now I'm replacing it with G, naming as Gaussian curve. But apparently I have added the third variable over here with small c as the controlling signal for the third independent variable. So we'll define A is equal to 1. That means amplitude is 1, obviously. So A is equal to 0.02. Now I have said you in the previous video that why I have kept A is equal to 0.02, but I haven't explained. So in this video I'll be explaining that. See, the thing is, if you keep this as small as possible, then the spreading of the Gaussian curve will be more. If you put the higher values, if the A is 2, 3, 4, then the Gaussian curve would be as narrow as possible. So it is just to control the Gaussian curve. Now I have done this. Now we will see the slicing commands. So this is defining the function, and this is defining the variables, or let us say in defining the independent variables. And finally we will be learning about slicing plots. So the thing is, we wanted to see at different cuts. For example, let us suppose, I'll just give an example so that you'll understand what I mean to say. So for that we need to write mesh grid capital X comma y comma z is equal to mesh grid x comma y comma z. So as there are three variables, so we are replacing it with 3, and then we have to write x slice. So if you want to see any cuts at x slice, then you can write that. If you don't want to see, then you have to just write rectangular brackets and nothing else. So Control C, Control V and Control V. Now this will be y and this would be z. So I want to see at z only. So -10. At -10 location I want to see, at -5 location, at 0, at -5 and at 10. So these are the locations I want to see. Now once I understood from where I want to see, now I want to plot it. So figure, let's say slice, the command would be slice. So x comma y comma z comma g comma x slice, y slice, z slice. Control C, Control V, Control Z. So this will be y, this will be z. That's it. So once you do this, we have to just run it. So unrecognized k variable. Sorry, this should be k. Yeah. So okay, so the thing is, I will stop this, Control C. So if you put Control C in the command window, the thing is, why it is running continuously is because I haven't terminated it with semicolon. So we have to terminate that with semicolon, and I will again run it. Now you will not face any problem. See, now you got slices at 10. Acha, okay, one more thing is, I have written both -5 and -5, they should be +5. Yeah, now you got 10, 5, 0, -5 and -10. So these are the locations you have got these slices. Now you are unable to see it properly, everything is in black color. So don't worry, you can see this is one of the best way to represent the distribution of fields. So it can be any field, thermal distribution, it can be magnetic field, it can be electric field distributions, it can be any field in whichever area you're working. So here you can see edges, right? So previously we used edge color none. So instead of that we can also use here edges none straight away. Edges none. So I can put control and at single time I can make everything. Okay, I can't do that. I have to independently do this. Okay, now you can see we got it right. Now similarly we can also convert this into jet, this into white. Now go to tools, go to rotate to have a better visibility. Now you see. Now it is clear that at center the field distribution is more, that is at 0 location, and at location 5 and 5 the field distribution is drastically reducing, and at 10 and minus 10 it has the least amount of distribution. That is what we are able to understand from this at different z cuts. Okay, so again I'll go back to this. Now yeah, if I want to see at different slices, let us suppose I want to see for some other slices. Then I'll put z slice 0 right now, and for x slice y slice I'll take minus 10 comma minus 5 comma 0 comma 5 comma 10. So I'll run for that right now. Now you see you'll get in this fashion. View property editor. So what I'll do is I'll copy this and directly I will take it in the same location over here. So you know we can have both the plots in same place to have better understanding. Just a minute. Yeah. Okay. So I'm just adjusting this graph so that to have a better visibility. Now the same thing we need to do. We need to remove the edge colors to none. So now we have done that. So can adjust it. Okay, now you have to take the tool, rotate 3D, and you can rotate like this. Now you see it is how interesting plot it is. Again this is happening even at 10 to minus 10 location also. When you go along the y direction also, at y is equal to 0 you are having the distribution of the field is greater. Obviously that is true, right? So that's what we are observing it. So from the observation it is very clear. we can this kind of field distributions are very useful if you want to see how the field is actually varying from one location to another location. Thank you.